Now that we've learned what systems of equations are, let's take a moment to learn how to solve for them using each of the three methods introduced in this first lesson. One of the methods is substitution, which literally means taking one thing and substituting it in for another thing. First method we'll be looking at is the substitution method, whereby we'll be taking something and substituting in for something else. Y equals 5x minus 2, and the second equation is 2x plus 3y equals 11. Now, to solve using the substitution method, you want to first of all isolate one of the variables, either get y by itself or get x by itself. That way you can plug it into the other equation. So you basically isolate something in one equation so that you can plug it into the other equation. So depending on how the question is written, you make a decision on whether substitution will be the best option. Because y is already isolated, we know that substitution will be the best method, because we can take this 5x minus 2, we know that that's really y, and we can plug it into the y value of this second equation. And let's go ahead and do that. The second equation would now be 2x plus 3, open parenthesis, 5x minus 2 equals 11, and that's substituting. So to solve for x, we would need to open up these parentheses. But before we do that, I want to remind you the problem with systems of equations. It's because we have two unknowns. So when you look at this system up here, we don't know what y is, neither do we know what x is. So when you're solving, your goal is to either get rid of the x's or get rid of the y's, so you only have one thing to worry about. And notice what happened once we substituted this equation into the y over here. We now only have to worry about the x's. So let's go ahead and do that. Distribute this 3 into both of these to open up those parentheses. We'll have 2x plus 15x minus 6 equals 11. And these are like terms, so we combine them. 2x plus 15x is 17x minus 6 equals 11. Of course, add 6 to both sides. The 6's cancel, so 17x equals 17. And to finalize, you divide each side by 17 to have x equals 1. Remember, however, that systems of equations have an ordered pair as a solution. So what we've done is found the x value of that solution. So we now know the x value is 1, but how can we figure out the y value? Very simple. We would take the x value that we just found and plug it back into one of the equations. It doesn't matter which one. You can use the first equation or the second, but I do want to encourage you to always go with the easier one. And in this case, we have a clear advantage in plugging it into this equation because it's just easier. Y is already by itself. So let's go ahead and do that. We would have y equals 5 times 1, because we just found out that x is 1, minus 2. So it becomes 5 minus 2. Therefore, y is 3. So when x is 1, y is 3, which means the solution to that system is 1, 3. This would be the answer to that system. Now let's try solving using the elimination method. With the elimination method, as the word might suggest, we will be eliminating something. And remember, the problem is that we have two unknowns. We don't know what x is, neither do we know what y is, so one of them has to go, so we have something that's a lot easier to work with. Now, one thing to remember when you're working with the elimination method is your goal is still the same, to get rid of either the x's or get rid of the y's, one of them. And you always go with the easier one. I'll show you how to make that decision. Sometimes you don't have an easier one though, so just roll with the tide as it comes. When you're using elimination method, you're going to be adding these two equations. You're basically adding this plus this, and this plus this, and this plus this. And as you add, you're hoping that one of these are going to disappear. Either the x's or the y's are going to cancel out. As things stand now, when we add these, nothing cancels because x plus 2x is 3x. And then we have negative 2y plus 5y is positive 3y. So you see the problem still persists. The only way that we can have something cancel, for instance, let's say we want to get rid of the x's, is by making sure we have the same digit here. So we have to have a 2. Not only do these digits have to be the same, one of them has to be the opposite sign. So we would need maybe a negative 2. That way, when you do negative 2 plus 2, they're going to cancel out. So we can't just stick a negative 2 here. That would be illegal in math. What we do instead is, since we've figured out that negative 2 will help us get rid of the x's and we'll have the y's to worry about, we have to make sure that the entire problem is multiplied by that negative 2. All right, so now to open up those parentheses, we'll have to distribute this negative 2 into all the terms. And let's go ahead and write the result of that right over here. So negative 2 times x is negative 2x. Negative 2 times negative 2y, positive 4y. Negative 2 times negative 11 is positive 22. And now notice, we don't really need this equation anymore, so we can just scratch it off. These are a new system right here. And remember, with elimination, you're always striving to add. And as you add, either the x's or the y's have to cancel. Well, let's see if that happens as we add downward. 2 plus negative 2, gone. Mission accomplished. 5y plus 4y is 9y. And of course, we have 14 plus 22, which adds up to 36. Now, to get y by itself, we simply have to divide each side by 9. And you find that the y value is 4. Remember, however, that the solution to any system is an ordered pair. So what we've done, we've found the y value of that ordered pair, and we know it's 4. So how do we find the x value that's associated with it? Just like we did with the previous problem, all you need to do is take the 4 and plug it back into one of these original equations. Doesn't matter which one. Just go with the one that you know is easier to work with. And I'm guessing we can use the top equation, this one over here. So let's go ahead and plug in 4 in place of y. It would be x minus 2. In place of y, we write the 4 in that we just found equals negative 11. So x minus 8 equals negative 11. To solve for x, we are adding 8 to each side. These cancel. Therefore, x equals negative 3. So we know the x value is negative 3, and the solution to that system is negative 3, 4. And now the third and final method for solving systems of equations is the graphing method. We briefly introduced this idea back when we were working on graphing linear equations. And remember that when you're graphing linear functions, one of the ways is by rewriting them into the slope-intercept form, which is y equals mx plus b. Well, when you look at each of these, it's not in the correct order because y is not isolated yet. So let's go ahead and isolate y for each of them. Well, the first equation is negative x plus y equals negative 3. To get this y by itself, we have to get rid of this x right here. So plus x over here, plus x over here. Those cancel, therefore y equals x minus 3. And now we have the equation in the correct format, y equals mx plus b. Let's do that same thing for the second equation right here. We have negative 3x plus 3y equals negative 9. And we want to get this y by itself. It's going to take several steps. First thing is to get rid of this by adding 3x. If you add it there, you have to add it to the right side as well. Those cancel, and we have 3y equals 3x minus 9. And we're closer to getting y by itself. We just need to get rid of this 3. And the way to do that is to divide each thing by 3. So 3's cancel here, y equals, 3's cancel here, x, and negative 9 divided by 3 is minus 3. So you now see that we have this equation and that equation to graph. But wait a minute. Remember what we said when we were introducing the idea of infinitely many solutions? If you glance at your equations, and you notice that they are the same exact equations, you have infinitely many solutions, because when you graph the first line, the second line will come and sit right on top of that first one, basically intersecting itself forever. So let's actually go ahead and show that. So to graph these, remember your y-intercept is your starting point. So we're graphing -3. It's a y-intercept, so it goes on the x-axis. And then we use our slope to show us where the next point is. So slope is 1, which means 1/1, rise 1, run 1. We want to rise 1 place, run 1 place. So we put a point there. Rise 1, run 1, point. Rise 1, run 1. Honestly, if you have 3 points, you have enough to then go ahead and join the dots. Of course, I should be using a straight edge, but being that I'm writing this on a computer screen, it's pretty hard to do that. I'm doing the best job that I can. That is the graph of the first equation. And of course, because these two equations are exactly the same, the second line is going to come and sit right on top of this, which means that we now have infinitely many solutions problem on this page. And just to recap, or rather summarize, when do you decide which method to use? Really, it depends on how the question is phrased. Graphing is typically the most cumbersome and least efficient method, so I never use it unless I specifically am asked to do it, or if I have to absolutely use it on a question. The elimination method, you want to use it whenever you have two equations that are stacked on top of each other in standard form. Remember, standard form is ax plus by equals c. When you have the x and the y on one side and the constant on the right side, well, use the elimination method. It's my personal favorite. And last but not least, you want to use the substitution method when one of the variables has already been isolated, or if it's not isolated, it would be easy for you to isolate. And that concludes this lesson on solving systems of linear equations.